So this is problem 6.28 from homework 6. Here we are testing two different proportions. We have the proportion of mothers who took prenatal vitamins whose kids have autism, right? So that's this number here. And the way that I found that number is I just click on it. I took B4, which is this value, right? These are the number of people who took vitamins and got autism, divided by the total number of mothers who took vitamins. And then we're comparing that to the proportion of mothers who didn't take vitamins whose kids have autism, right? So that's 111 divided by 181. We want to know, are these two proportions different from each other? I mean, they look different, but are they statistically significantly different? So that's what we're trying to find out. We want to know, is the proportion of people who took vitamins whose kids have autism the same as the people who didn't take vitamins whose kids have autisms? So in other words, the null hypothesis is going to be the difference between these two. The proportion of people who took vitamins minus the proportion of people who didn't take vitamins is 0. That's what we would, if there is no effect, we would assume that this difference is close to 0, right? So this process is pretty well outlined in chapter 6.2 in these pages, 217 to 220, but I'll go through it here. The pooled proportion we have to figure out. Let's see, let me pull up the book and I'll show you the exact equation here. Pooled proportion, oh, it's right here. So this is our pooled proportion. This is our pooled proportion. We have the number of successes, right, which means kids having autism. So it's the p hat times n1 plus p hat times n2, right? So this represents the people who took vitamins whose kids got autism times the number of people there were, and then the proportion of people who didn't take vitamins whose kids got autism, all divided by the total number of cases here. And so that's what I'm doing in this number here, right? If we look back, B7, this is our proportion here of people who took vitamins times the number of people there were, so 302, right? And the number of people who didn't take vitamins times the number of people there were from that group, so that's 181. And then I divide that whole thing by these two totals added together, right? So that's where this formula is coming from. You might realize that really, like, if I take this proportion and I multiply it by this number, I just get 143. So, and if I take this proportion and I multiply by that number, I just get 111. So I could have just taken 143 plus 111 and then divided it by 483. And that's the same as my pooled proportion. Maybe that's an easier way to calculate it. I'll just do it again. Let's just do it again for fun. So this number plus this number divided by the total. Oh, look, we get the exact same number. So however you want to think about it is fine. If you want to follow this formula exactly, you can. If you want to just realize that it's just your success cases divided by the total number of cases, that's fine. That is what the pooled proportion is. We have to use the pooled proportion to estimate the standard error. So let's go scroll down in the book to the standard error example. So you'll recognize the standard error for when we do one proportion, but since there are two proportions that we're trying to know the difference of, we have to use both of these proportions. And more confusingly, we have to use the pooled one twice over the different totals. So let me show you what that looks like for our problem. Here we've got the pooled proportion twice, so B13, that's my pooled proportion here, divided by the total of people who didn't take vitamins. And then I'm going to add to that the pooled proportion again, just like I did when we were doing single proportions, and I'm going to divide it by D4. So that's this total here. And that's my standard error. And so our distribution looks like this. We can say that the proportion, actually this should be vitamins minus the proportion of people who didn't take vitamins, no vitamins, roughly has a normal distribution with a mean of 0 and a standard error of 0.0496 or 469. So this is what I'm using for my test statistic. The test statistic now is exactly the same as we've done before. We just do our normal z-score remember we are looking at the difference between these two. So B7 minus B8, the difference between these two proportions here. So I subtract those two, right? I was assuming that the difference would be 0, so that is my mean here. So I've got the difference minus the mean over the standard error that I calculated. So this is my test statistic. This gives me this p-value, but this is a two-tailed test that we're doing, so we have to actually multiply this by 2. We have to now compare this number to our alpha, but we can actually compare it to, so it depends on how we want to think about this. We can compare it to half of alpha, that's this number, but then we'd be comparing this p-value, or we can compare it to the full of alpha, which is 0.05, but then we could be comparing that value. So we could either do, let's do it the way the problem wants us to do it. 0.0029 is less than 0.05, so we will reject the null hypothesis. Just to make clear what I was saying before, that is the same as just doing one tail times half of alpha. It gives you the same answer. 0.0045, 0.025, right? Let me show you what that looks like on the normal distribution here, right? So here's our normal distribution, the standard normal with a mean of 0 and a standard deviation of 1. We're interested in looking at the very left-hand tail, which is less than our test statistic of negative 2.98, right? That's our test statistic here. But also the very right-hand tail, because it's a two-tailed hypothesis. We decided that our alternative hypothesis and when they're not equal. So this area plus this area are smaller than the alpha that we decided was acceptable, or 0.05. We didn't decide it. It's not even given to us in the problem. We're just assuming that that's it. Do I need to say anything else? So here's our conclusion. It's unlikely that the proportion of kids with autism whose mothers took vitamins is... Oh, let's change this. I have two negatives here. Changes. Is equal. Okay. Let's make it big. It's unlikely that the proportion of kids with autism whose mothers took vitamins is equal to when mothers did not take vitamins, right? So those are different proportions. That is what we were saying. So we look at which one is less, and it turns out the proportion of people who took vitamins was this number, which is smaller than the people who didn't take vitamins, right? And their kids got autism. So we should conclude that you should probably take your prenatal vitamins so your kids don't have autism. Although, you know, that would be our conclusion. All right, that's a lot. Feel free to post if you have any more questions. Okay.